say, from yesterday? Eva?
Number 5.
Number 5. Give me a second here. Number 5. Okay, on number 5 there, let me go backwards just for one real quick, just from yesterday then. Look at number 4, okay? Looking at number 4 here. As I said yesterday on the GCF, typically if the lead coefficient starts off with negative, so we bring out the negative. And I say that, and I look at the answer here on number 4, and the answer key did not do that. Typically we do though, okay? So the software that I use on number 4 is not bringing out that negative, but typically we do bring out that negative on that. That answer is fine, okay? That answer is fine. But really what we should have done on number 4, you're going to see more times than not happen here is on number 4. The GCF starts off as a 3k to the 6. That's definitely starts to be off correct. Remember we said for the GCF yesterday, we start with those coefficients, 15, 3, and 3. What's the largest number that divides into 15, 3, 3? That is 3. Okay, so that is fine. And for the k's, remember they all have to have k's in there. They all do. And then we can only take out the smallest amount that's there. And as we look at those exponents, those degrees, k to the 6 is the smallest one. So we can only bring out that k to the 6. I can't take away something I don't have. I can't take away a k to the, say, 8th. I don't have k to the 8th here nor here. So I can only take away something that the smallest amount that I have there. Again, that's what we call as the GCF, the 3k to the 6. Now again, because the lead coefficient's negative, typically we bring up that negative with it. Okay, so they didn't do it on that one. It's not wrong, but usually we like to bring it out. So I would say the negative 3k to the 6 is what we got. Now, how do we show what we have left over? Well, we said we're undoing what operation? We're undoing multiplication. When you undo multiplication, what's the inverse of multiplication? Division. So we came around yesterday and we divided everything through by what we factored out, that GCF. So then you slowly divide. Okay. Negative 15 divided by negative 3. And here you bring in your exponent rules from about 6th grade. K to the 8th divided by k to the 6th. 8k's divided by 6k's remains you how many k's? K to the 2nd, right? 3 divided by negative 3, negative 1. K to the 7th divided by k to the 6th gives you how many k's? Just 1 remains. And then lastly, what do we got here? Negative 3 divided by negative 3 is a positive 1. K to the 6th divided by k to the 6th. 6k's divided by 6k's, how many can cancel out? All of them, right? So I got to be left with something, and that's that plus 1 that's there. That answer I would say is a little bit, I would say nicer, but it's probably more common than what you run across in Algebra 2 next year with your teachers, okay, is bringing out that negative. If you left that answer, you looked at the answer like, oh, the answer key did not bring out that negative and you wrote that, that's fine, but that's probably more or less what you're going to run into, okay? Now, bringing it back to, say, number 5, the GCF here at number 5, that's the GCF where it's staring you in the face. This GCF is, and obviously you can tell in both terms here, that y minus 2 is a binomial. Here we say the GCF is a monomial. It's 1 term. Here it is 2 terms. So we're taking it out from this first term. This is 1 term, and then this is the 2nd term. So we're taking out from those 2 things. So if I take out a y minus 2 from right here, and then I take it out from right there, again, when I say take it out, I'm undoing multiplication. I'm going to divide. So I bring out a y minus 2 from these 2 locations. Hey, there it is. I'm left with just that y. I take out a y minus 2 from right here. What am I left with right here? Just a plus 3. And that's where you're going to see then a binomial left with typically a binomial as well. Okay, off of that. Alrighty, Eva? So don't these right here, I would say like a special case of GCFs, but that GCF is like, hey, look at me. I'm a special case. I'm standing right there in the face. Okay. All right. Keep going. Anybody else have another question there, Brianna? Which one? 9. All right. Let's flip it. We'll go 9. Biggest thing on 9, expand it out. Okay. Remember that squared there. Rewrite that. If you did 10, if you did 10, fine. Number 9 is the exact same way. Just expand it out. And this is going to be a good segue into today's notes because we're going to use this to help us out in just a few minutes to kind of undo everything. So remember, go through and distribute. Just you got to expand that thing out though. 4a squared, and then what? Negative 4a. Then come around, distribute the negative 2. And then what do we got? Negative 4a, and then what? Plus 4. Combine like terms. Those right here in the middle are my linear terms that can combine. And that's where I'm getting that negative 8. Okay. But remember that quantity squared. Remember, expand that out and go through and distribute. Okay. Anything else anybody's got? These are all good questions. This is your last chance here. Going once, going twice. You get more practice with the GCF over this week, and well, we're about to factor in the next one. All right, make sure your name's on the drum basket. All right, double checking my work, your work. Let's make sure we got this right polynomial that's been created right here. 7x squared, right? 27x, and what? Negative 4. And what is that type of polynomial there? That is a, I get those two things reversed, don't I? The name is, I get the, who cares? This is a what? Whatever. It's a quadratic trinomial. It is what it is, people. We know what to do. Okay, it is a quadratic trinomial, right? So, what we want to go through and do today is you can see on your notes there today, really the next couple pages of your notes. This is pretty much all you see. You see a bunch of quadratic trinomials, maybe a few quadratic binomials pop in there as well. What we want to go through and do is undo all that. Okay, we want to go through and factor these into some way, somehow, get it back into a product of some type of binomial times a binomial. Maybe it's going to be going back to what we did yesterday. It just kind of depends on what's in front of you. But as we work through here today, let's get going here. How in the world can we make that 5x squared plus 9x minus 2? How can we factor that such that it's going to end up looking like those two binomials? Okay. So let's go through and talk about that. Let's practice it out. That's where the big skill is at right now. All right, let's do this. As we do this, got to think, first thing is make sure you're in standard form. If you're not in standard form, rearrange it, but we are. Cool. Next thing is, let's go through and identify the A, B, and C. The A, B, and C, remember, is coming from that standard form. A is that ax squared, again, bx plus c. A in this instance is what? A is 5, B is what? 9, and C is what? Negative 2. Okay, so we want to look at what is the quadratic term, what's the coefficient, I should say. What's the coefficient of the quadratic term, what's the coefficient of the linear term, and what is the constant. You got to know your bits and pieces. Okay, now let's come back and dissect what we just created. Okay, the A, B, and C, they're all being created by either multiplication or combination of multiplication and addition. So when we look at the A, B, and C over here, well, what turned out to be the A, B, and C here? The A is what on this one? A is what? 7, B is what? And C is what? Okay. As you look at the A, B, and C on this one, which terms, the A, B, and C, which terms are created solely through multiplication. Just by multiplication, no addition was happening. Which one? A and C, right? A was created solely through multiplication. How did I get that 7x squared? 7x times 1x, right? That gave me that. And then Eva said -1 times 4. That gave me -4. That was it. That gave me just multiplication happening. How is B being created? B, 27 is being created by what? Some addition happening, right? Okay, I'm going to pause on B right now. I'm not going to worry about that. I want to focus on A and C. So back to my problem at hand. What I'm going to now do here is I'm going to focus always on A and C. I want to list out the factors of 5. How do I get factors? What are factors of 5? When I say factors of 5, what two numbers multiply to give you 5? 1 and 5. So I'm going to list out factors of 5. And I do the same thing for C. Whatever C is. Well, C is -2, right? What are numbers that multiply together to give you 2? 1 and 2, right? Okay, so I'm listing out factors always of A and C. Because A and C are always being created through multiplication, strictly. Okay. I always compare factoring to like a puzzle. What's one of the first things you do with a puzzle? What's that? Not edge pieces yet. It's the first thing you do with a puzzle. Carter, put the phone away. What's that? Spread them out and also flip them, right? So that all the pieces are facing up, right? So I kind of am comparing this to this right now. I'm getting all my pieces set. I'm finding all my factors. I'm getting all the pieces lined up to face forward. So that's what I'm doing. Now the next thing you usually do is find the what? Edges are the corners, right? That's where I'm at right now. So that's what we've got. We've got them all faced up, and I'm looking at the corners. So here's where I'm starting to build the two quantities. So back over here. That 7, like you said, and that -4 created through multiplication, that is giving me that 7x and that 1x right here. So that's going to be creating my two quantities. This A starts it off. That A is 5 and 1 that you told me, 1 and 5. That's going to start building my two quantities. Because how is that A created? It's created by what? 5x times 1x, right? 5x times 1x is what? 5x squared. That's always going to be true, okay? That's always going to be created through that multiplication. Now, before I throw in my other piece, C, 1 and 2, let's think about these signs. This is created through multiplication. It's not just 2. The constant is a -2. So what's got to be true about the signs for negative in multiplication? I'm sorry? One has to be negative, and what? One has to be positive. You got to have opposite signs, right? So we got to have a positive and negative. Now, where it goes, we don't know yet. And this is like a puzzle. You're like, oh, this piece is going there. Does it go there sometimes? It doesn't. So we have to sometimes move it around, right? This is the same thing that's happening here. So the method that we're working on here today, in math we call this guess and check. Okay? So we're going to make a guess. We're going to throw our guess out there. Where 1 goes, where 2 goes. Where the positive goes, where the negative goes. I'm going to throw a guess out there. We're going to check our guess. And if we're good to go, it should take us back through 5x squared plus 9x minus 2. If my guess is not good and we checked it, okay, then we're going to make a new guess. So I'm going to play dumb here, which may not be an act. All right. I'm going to say, hey, I'm going to put a 1 here. I'm going to put a 2 there. I'm going to say this is plus, and I'm going to say that's a minus. I have to use that 1 and 2 because why is that I got to use 1 and 2? This is going to be created through multiplication, right? 1 times 2 has to give me that 2, right? And you told me one has to be positive and one has to be negative. Now, which one is plus and minus? I'm not 100% sure yet. All right? But I know one of them has to be positive, one has to be negative, because I have to get a negative 2 here. Now, what I'm going to do here is I'm going to go check my guess. This is my guess. And what do I mean by check my guess? Go through and do now the distributive property and go through and see if you get that linear component. Do you get 9 in there? Why do I go check through and look at that 9? Because how does that B get created? B is created through what operation? 28 plus a negative 1. What operation is that? That's addition. You got to find B at the very end. B is being created through addition. You can't find that B until you put in those different pieces right there. So let's play the guessing game now. Let's go play the checking game. 5x times 1x. Hey, that looks good. It should. It's pretty hard to screw that up. It's possible, but it's pretty hard. 5x times 1. Now we distribute the negative 2. This is why last week I said you can't be just good at it. You got to be great at this skill. You're going to get a crap ton of practice of it. Now we distribute the negative 2. Negative 2 times 1. Hey, there's my A and C. These two things are always checking out. Again, it's pretty impossible to screw this up. I mean, it's totally doable. But what I'm really looking for are these two linear terms. Are these linear terms adding up to what? And did we get a 9 out of it?
Nope.
Well, that sucks. What does that mean? I made a bad guess. Okay? So I need to fix things. Now, fixing things might entail, oh, I should have made this a plus 2, and I should have made that a minus 1. Maybe something that simple. So I'm going to make that new guess. Okay? Again, I'm playing dumb here. So I'm going to now come back around and check my new guess. And I'm always going to, I try to put a disclaimer at this point. You're going to get ticked off because you're going to be guessing things. And some of you are going to be quicker guessers than others. You're going to see the structure happen faster than others. Cool, great, more power to you. Some of you, it's going to take a little bit of practice. Where you may not be quick on the draw. It might take you 3 or 4 guesses down the road to finally where it clicks in. Be patient, it happens. All right, 5x times 1x still checks out. Right here's where I'm at. 5x times negative 1. That's a negative 5x. 2 times x is a 2x. 2 times negative 1 still is that negative 2, but what am I always looking for? A linear term of 9. Am I getting a 9 out of negative 5 plus 2? That was a bad guess. So now what does that mean? Well, maybe I should be moving the 2 and the 1. Maybe I put the 2 and the 1 in just completely the wrong spots. I'm taking the long road here today. All right, so let's try this out. I should just take a long road here. 5x times 1x. Again, I'm not moving that. That's set. That I know is working. 5x times negative 2. What's that give me? Negative 10x, right? 1 times x is a what x? 1 times negative 2 is a negative 2, right? Right here, this is where I'm checking that linear term. That linear term is where I'm focusing on. That sets everything. Did I get a 9 out of that? No, I didn't. I get a negative 9. What do I need? I'm so close, ain't I? So I am so close. I need a positive. I have a negative. So when I get that close, I just have the signs are opposite. What that means is you are so close there, flip the signs. So what does that mean? I need a negative here, and then I flip the signs. That's what does it for me. This becomes a plus 10, that becomes a minus 1, and what's 10 minus 1? Finally, I found it. I took the long road, I told you. This is what we want today. The factored form of 5x minus 1, x plus 2. Okay? We call this guess and check. Some of your guesses are going to be better than others. Some of you don't go down into the boat because you have no luck. All right? But there is a structure here. Okay? If you're not seeing that structure right now, the first one, okay, give us some more practice, some more examples. You'll start to see the structure. You'll start to see the shortcuts happen. Some of you, it happens just more quickly than others. That's one. Let's do another one. Okay? Let's go down to number 3. Let's do it out. Are you in standard form? 7x squared plus 29x plus 4. Is that standard form?
Nope.
It's got to be in standard. Identify A, B, and C. A is what? B is what? And C is what? You're always going to identify the factors of A and C. A and C are always created through multiplication. So list out the factors of 7. How can you get 7 through multiplication? 1 and 7. Always look out the factors of C. How can you get 4 through multiplication? I'm sorry? 1, 2, 4, I heard. So 1 and 4. And what's my other pair? 2 and 2. So on this instance with C being 4, you've got 2 groups. You have 2 possibilities. Either that 1 and 4 is going to work, or you're going to toss it and you're going to use that 2 and 2. It just kind of depends right there which group is working for you, but they both will not work. So this is another kind of just wrinkle in things here.
You guys want to take a picture for the yearbook?
Okay. So from there, with that now, we can start building our 2 binomials. Okay, we've got our pieces laid out. The A starts like acting our corners. 7x and 1x. Okay. 7x and 1x that acts like their corners. Now, before I start choosing A's, it can be 1 and 4 and 2 and 2. I want to think about these signs. 4 is positive. How can you get a positive through multiplication? It's got to be true about the signs. Or they both got to be positive, or they can both be negative, right? They just got to be the same. So don't forget, they both either got to be positive, or they both got to be negative. They got to be the same sign. 2 negatives make a positive. 2 positive make a positive. In this instance, go back. You got to look at that linear term. The linear term puts the nail into it. Linear, there's no negatives up here, is there? So because there's no negatives up there, which option are you going to choose? Both pluses, right? So let's put those pluses in there. If the linear term was negative, well, what are we going to choose? Both negatives, right? So we're using those 6th, 7th grade negative skills that you start talking about. Okay, now we got to make a guess. You want to get a linear term up to 29. So you want to take a guess, so you can use the 1 and 4 pair, or you can use the 2 and 2 pair. And then after that, you got to think about where you're going to throw that 1 and 4, or where you're going to throw that 2 and 2. I guess there's not really an option with 2 and 2, is there? Okay, but what pair are you going to choose? Jillian, give us a suggestion here.
Put the 1 in the center.
She's choosing the 1 and 4, and she says throw the 1 where?
With the 7.
With the 7, and then the 4 there. That's Jillian's guess. Don't go and just say we're done. You got to check that guess. You got to make sure it's turning out to be going back to the original. Really, are you getting that 29? Go check your guess. So this is where, again, I'm telling you, you're going to get a ton of practice with the distributed property. Go check it. 7x squared, pretty hard to screw it up. 7x times 4. 1 times x, 1 times 4. There's my A and C. Only through multiplication is that happening. So that's, like I said, pretty hard to screw it up if you list out those factors. What I'm focusing on is this linear term right here with those 2 created through addition. Does that give me a 29? All right, Jillian didn't take us the long route, did she? 1 and 4 in those two correct locations. That's the only possibility that's happening. I can't flip them around. The 2s are not going to work. Jillian, thank you. We're done. That is the only suggestion that's going to work. Plus you. 7x plus 1 and x plus 4. That's it. That's how that's going to factor into those two binomials. Okay. All right, let's do another one. Is it in standard form? Rearrange it. You can't tackle it until that's rearranged. So this takes us back to last week where we talked about standard form, rearranging things. Now that you're in standard form, identify A, B, and C. List out the factors of A and C. What is A? A is what? A is 11. B is what? And C is what? Get-doke. You always list out the factors of A and C. As we've demonstrated now a couple times, B is created through addition. Factors of 11. Factors of 2. Okay, I've got all my pieces kind of, again, laying up. A is like my corner pieces. I start to build that with my binomials. 1 and 11 you said, so 11x and 1x. Okay. Now to make my life just a little bit easier, I want to keep track of these signs. What do I mean by keep track of these signs? How you said it's a 2. It's a positive 2. How can I get a positive through multiplication? Same sign or opposite signs? Same signs, right? And what do we got to know about those same signs? Both pluses or both minuses? Look back at the polynomial. I'm sorry? Both minuses. It's a negative 23. And the only way you get a negative 23 is they both got to be a negative in there. 2 negatives make a positive, but eventually they'll add together to give me a negative 23. Make a guess if you haven't done so yet. Where does the 1 go? Where does the 2 go? Now here you only really got 2 options. It's pretty hard to screw it up. It's doable, but make a guess. Now, I'm going to make a dumb guess. All right? This is my original guess. I say it's a dumb guess because as I go through and check now my guess, there's my 11x squared. That's fine. 11x times 1. And I distribute my negative 2. Negative 2x. Negative 2 times negative 1. There's my plus 2. That looks good. A and B. Sorry, A and C. But that's a negative, what, 13? And what do we want? We want a negative 23. So that's not quite. So the only thing I could do is flip around the 1 and 2, right? So the correct answer should be 11x what? Minus 1 and x minus 2. So now I'm going to go back around and say 11x minus 2 is what? 22x. And negative 1x right there. And what does that give me now? Negative 23x. There we go. That's my factor form. That's all we can say. Okay? All right. Let's keep going here. Let's go C. All right? It's all about the practice. It's all about the practice. Take C, put it in standard form, I believe, because it's not. C is not in standard form, so put it in standard form. Rearrange it, identify A, B, and C, factors of A, factors of C. If you haven't, it seems like I've said this several times before, it's because I have. Okay, guess and check it. 3x squared, 13x, and a 14, both pluses. Factors of A, factors of C. Factors of 3 and factors of 14. Guys, what's the factors of 14? Yep. And when you listed out 1 and 14 and then I heard 2 and 7, don't keep track of those in your head. As you'll see more probably tomorrow or Friday, those factors are going to, the amount of factors are going to increase. If I said 48, what's factors of 48? 6 and 8, 4 and 12, 1 and 48. Keep going. 2 and 24. Keep going. 3 and 16. There's 5 pairs of factors. Don't keep track of those in your head. List them out as we've been doing and go in an order. 1 and 14. So what I'm doing as well as I list those out, I'm taking that 14 and dividing it by 1, 2, 3, 4, 5 and list them out in order like that. Okay? They will increase in size very quickly. List them out. Don't keep track of them in your heads. You got enough you're doing. Try to keep track of this. Okay? And the other thing is now, what are we going to know about the signs? Positive. They got to be the same, right? Same signs. In this case, both positives. It's a 14. And the only way to get a 14 is either positives or both negatives. But in this case, there's no negatives. And then you got to make the guess. What are you going to do? 14, 1 and 14, or 2 and a 7? 2 and a 7, I hear. And then the question is, where's that 2 go? Where's that 7 go? The order does matter. So Eva, where's your suggestion for 2 and 7?
7 goes in my first, and 2 goes in my second.
So check Eva's suggestion. And what again I'm sitting up here doing is this right here. I'm doing my distribution to check my guess. I'm not doing any type of magic or anything like that. Okay, I'm doing my distribution in my head to see 3 times 3 times 2 is a 6x. 7 times 1 is a 7x. And 7 times 2. Hey, there's my A and C as it should always be. It's that linear term I'm focused on. Did Eva get us a 13 out of that? Sure appears to be, right? There we go. There's my factored form. Okay. All right, let's flip. Let's do, say, one more here. Let's take a look at letter E. What do you notice slightly different on letter E? There's no what? There's no C, is there? A is what? 2. B is what? I'm sorry? -1. And C is 0, right? Okay. So when we have C is 0, Deontay said there's no C. C is 0. Pause and everything we talked about today. It's not going to help you out. Go back to yesterday. What we talked about yesterday? Right. You got to do the GCF. Okay? When C is 0, GCF it. Okay? You got to do the GCF. So, think about what we did yesterday now to the greatest common factor. All right, what did we do yesterday for the greatest common factor? The coefficients. 2 and there's a 1 there. Greatest common factor for 2 and 1. It's just 1, right? Largest number for that is just 1. Now for the x's. They both have x's, that's great. So how many x's can I pull out?
1.
Just 1. I can remember only take out the smallest amount that are there. In this case, it's x to the first. So I'm going to bring out an x to the first. There's my GCF of 1. And if I take out that, when I say take out, I'm undoing multiplication. Undoing multiplication, as we said, is division. So I'm not doing what we talked about today. I'm not factoring that trinomial with a and c and all that. I'm doing the GCF. 2x squared divided by x is 2x. Negative x divided by x is -1. And then we're good to go. Okay, you got to do the GCF. There's no other way around it. Okay, let's go next door to letter F. We're back to trinomial, aren't we? So you're going to see a little bit of everything thrown out to you now. We saw GCF just now. Let's pivot back to trinomial. It's in standard form. A is what? B is what? C is what? Not 56. Make sure you carry that negative. Those dang negatives and positives, those negatives will screw you up. You got to take those negatives. And we always list them out. Factors of A and C. A is 1. Factors of 1 are 1 and 1. Yeah, that sounds odd to say it, but factors of 1 are just 1 and 1, aren't they? Okay, this is where I was saying a few minutes ago. Pause and take a second to list out the factors of in order of 56. Don't try to keep track of that in your head. 56, first pair is 1 and 56. Start dividing by 2, 3, 4. 2 and 28. 3 go to 56. Calculators, this is where your calculator might be handy for. 3, no. 4? 4, I believe. 4 goes in there how many times? 14. 5? No. Excuse me, no. 6? No. 7? 7 and 8, right? 9. And once you hit 8, you've already taken care of it, haven't you? So we're right back around. That takes you all of 15 seconds. It will save your life eventually. It may not literally save your life, but makes you not lose your patience as much. And before I start doing everything, what's going to be true of my signs? Opposite signs or the same signs? So let's keep track of that. One's got to be positive, one's got to be negative. Where it goes, we don't know yet, but keep track of that. One's plus and one's a minus. All right. You got 4 pairs. Which pair are you going to choose from? Keep in mind, what's my end goal here? What's my end goal? -1. Anybody have a suggestion off that? 7 and 8, says Eva. Anybody else want to go with something else, or are you going to take that 7 and 8? I would take the 7 and 8 as well. And which one do you put the positive on, the 7 or the 8?
7.
All right. So that's Eva's suggestion. Go check it out. There's that 1x squared right there. -8x. 7x. -56. A and C checks out as it should. Linear term is what I'm looking for. -8 plus 7. Does that give me that -1? It does check out. Okay, so we were good to go. The other 3 pairs, not happening. If you chose poorly and said 2 and 28, it's never going to happen. 4 and 14, never going to happen. 1 and 56 works. Okay, or sorry, 1 and 56 doesn't work. 7 and 8, that's the only combination that works. It's got to be the +7, and it's got to be the -8. Now, can you have those quantities in the different order? X minus 8 and then x plus 7? Yeah, that's cool. That doesn't matter. Okay? All right. We're going to do some more work on here tomorrow, but I'm going to see if I can finish this really quick here with you. This is going to lead us into some parabola work. Okay? Take our last thing here, and what we're going to do then here is we grab half of this parabola. Okay? And tell you what, we're just going to save this for tomorrow. Okay? We'll pause. We'll finish this up tomorrow. Okay? Now, with yesterday.